we proved both the theorems of the existence of equilibrium by supposing, in particular, that excess demand correspondence or excess demand function is defined also for price system with some null component. But if you remember consumer theory, the first part of the course, it is possible that when price is equal to 0, and the budget constraint of the consumer and this form, VH of P, and preferences are strictly monotone, there is no optimal point, because by simply increasing the quantity of the good whose price is 0, which is implies no expenditure, you can increase your utility or preferences without limit. So if P has not all positive components, it is possible that Z of P is empty. However, it is easy to cope with this particular case by simply supposing strict monotonicity of preferences. Because this property of individual preferences has an important consequence on the excess demand correspondence. In effect, take any sequence of price system which tends to a certain price system P, which is not a positive vector. In other terms, it has some null component. By strict monotonicity of preferences, you can show that the limit for me, there's a step. Take any sequence Z of excess demand vector such that for every n in large M, Z belongs to large Z of P. In other terms, Z is an excess demand vector when the price system is P. Well, if individual preferences are strictly monotone, you can prove that the limit for n which tends to infinity of the norm, that is the length of this vector Z tends to infinity as well. If you suppose that this property is verified, it is impossible that the equilibrium price system has some null component. And we can prove by using the same lemma as before, suitably modified, that there exists an equilibrium price system in delta which has all positive components. And therefore there are no free goods. This theorem can be proved in a similar manner by using the same lemma as before. But the proof is much more complicated. So I limit myself to illustrate this result. I repeat, if when you have any sequence of price systems which tends to a limit price system which has some null component, and you have a sequence of excess demand vectors such that any Z belongs to Z of P ni, then in the limit the norm, in other terms the length of a vector Z ni tends to infinity as well. In this case you can re-demonstrate the existence of equilibrium by means of our previous lemma, and moreover the price system has all positive components. There are no free goods, and so there are no superabundant groups, according to one of our previous results. However, since this theorem is much more complicated than the previous ones, I limit myself to state the result. The fact that for some price system which null components choices are not defined for our consumers can be, however, coped with by means of a suitable procedure which I shall illustrate without any real proof, however. Consider a pure exchange economy to make things simplest. So there are each consumer, each households, which maximize their respective utilities or preferences. Well, let us suppose that the preference relation of any subject H verifies the following property, which is a reinforcement of convexity. In other terms, pH is starred. This means that for every pair YH, XH, which belongs to pH, and for every lambda in 0, 1, lambda times YH plus 1 minus lambda times XH is another element of pH of XH. This means that if you have any point XH and any other point YH which is preferred to XH, as in this case, then every point which lies on the segment which unites XH to X to YH is preferred to XH, like for example this ZH. These are the so-called styled preferences. If you saw this property is strictly connected with convexity. It can be deduced by convexity, openness, preference, and so on. Or let us introduce it as a separate property. If you suppose that besides all the other properties, preference relations verify these assumptions, tiredness, well, you can prove the existence of equilibrium even if for some price system as before, choices are not defined for some consumer. How to obtain this result? Sorry, this part is not really included in the program of the course. I limit myself to illustrate this result because the proof would be excessively difficult. So I limit myself to the main points, but it's not a part of the program. Well, in order to demonstrate the existence of equilibrium also when some price may be equal to zero, Debré considered the so-called modified economy or truncated economy, which is, of course, derived from the real economy. Let's consider any subject. Since this is a pure exchange economy, you have an initial total endowment of goods, which is simply the sum of different initial endowments of each household. This is the total initial endowment, denoted by omega, without indexes. This is the total initial endowment. Let us consider this endowment, total endowment, omega, and put attention, sum to it the vector, the unit vector E. This unit vector in reality is the vector with all the components equal to 1. So you pass from omega to omega plus E. Now, consider any price system. This is the initial endowment of subject H, which clearly has the components less of the total initial endowment of all subjects, and consider the budget constraint. It's clear that for some price system, this budget constraint has some point with some components greater than the component of omega plus E, obviously. Particularly in the case in which the price, say, of good one is equal to 0, the budget constraint has this form. There's a large part of this set. Almost all the budget set is outside this set. Or, this is BH of P. Now, consider the truncated budget set, which is denoted by B cap H of P, which is simply the set of all the XH which belongs to BH of P, such that XH has all the components less or equal to omega plus E. The truncated, the modified budget constraint is substantially this set. You cut off all the points which has some component greater than the corresponding component of a vector omega plus E. This is a so-called truncated budget constraint. What is the difference between the original budget constraint and the truncated one? It's simple. While the original budget constraint may be unlimited if some price is equal to 0, B cap is always limited, because it's truncated as a substantial subset of original budget set included in this compact set. So it is always compact, non-empty, compact and complex. And therefore, if preferences are continuous or open, there is always an optimal point in this budget constraint, even if some price is equal to 0. Clearly, the optimal point could be in this point, but also in this point. This is not really an optimal point with reference to the real budget constraint, because in the real budget constraint, the optimal point would be this, alpha, say. But in the truncated budget set, it becomes beta. However, beta always exists if preferences are continuous, even if some price is equal to 0. But natural observation to this is clearly, but this truncated set is not the real one. So it is immaterial to know that there is always a choice in these fictitious budget constraint. The real problem, if there is a solution to the maximization problem in the real budget constraint, in this budget constraint. It is not so, because if preferences are stored, then any equilibrium of a modified economy is also an equilibrium for the real one. So you can avoid the problem of unboundedness of a budget constraint in this simple way. So let us have a small break, and then I shall show you how this result can be obtained.